you know, normal stuff that we already. I forget why I put this in there. Oh, it's probably someone who didn't do any symbios and comes out at the end of the semester and starts crying. And I'm not going to die. You are. Okay. Also, like I said, I'm into, you know, sex and death. It's Woody Allen, if you know who that is. Okay. Okay. Any ideas about what science is? Please, someone? Yeah.
Theory?
What is that?
Theory?
Theory. About what? Okay. Theory. Actually, that's great. Okay. That is really good. What's a theory?
An idea.
Okay, an idea. Okay. Actually, theories are a whole bunch of ideas and explanations for a kind of a larger concept or framework. So, like, there's theory of gravity. The first one proposed was by Isaac Newton. It was replaced by Einstein's theory of general relativity 300 years later. Those are theories with a lot of different explanations and predictions. Like one of the predictions that Einstein made was something called gravity waves that you might have been hearing about. That gravity is actually not a force so much as it's how space-time is bent depending on the mass and the energy present. And so one of the things he predicted was that we would be able to detect gravity waves from very large objects like black holes. And in fact, recently some scientists set up an experiment and they actually detected the first gravity waves. It's also, gravity waves is the name of a company I have. It's called Gravity Wave Therapeutics, and I'm going to use gravity waves to cure people of everything. So you've heard it here first, okay? I just want you to know you should probably buy. It's going to go on the stock market. It's going to make lots of money, and it's going to cure you of cancer. It's going to cure you of false eyelids. It's amazing. Okay, so gravity wave therapeutics, remember that. Okay, so anyway, that was one of the predictions that Einstein made that's what the theory made. And in fact, that prediction has been upheld. And so that's another piece of evidence for a theory. Okay. An explanation or idea is a hypothesis, and a lot of times you have lots of different hypotheses for different aspects of a theoretical framework. Anything else for science? Any other definition? Oh, there was already someone in the back. That's right, I picked on you. You're in the back, it's good. Okay, what is science to you? Don't be afraid.
Science,
Forget about, there's all these people in here. They're gone. We're on the beach together. No.
science, I guess. Kind of already said explanation, so I kind of like getting a deeper understanding of like all the different aspects of science, so evolution and meiosis and mitosis and all that stuff.
Yeah. Okay. Getting there. One thing science isn't is a bunch of facts. Science is, it's actually, oh, here we go. Okay. It's actually a process that poses explanations and then allows you to test them. What is that process called?
Experiments.
Huh?
Experiments.
That's part of it. The overall,
Scientific method.
yeah. Okay, so that's actually what it is. Now we think of science and we think of experiments. Experiment is part of the scientific method. We're going to be going through the scientific method, but it's a method for gaining knowledge. There's a lot of different methods for gaining knowledge. We have some people might take philosophy classes, historians, business, religion. All these ways are ways of gaining knowledge. Some work better than others in terms of reliable knowledge, knowledge that you can actually bank. But science can answer everything. In fact, actually, that's why science is so great. Science can be wrong. By being wrong, it means that you can actually be right eventually. But you never actually prove anything in science with experiments. All you do is you gain more and more evidence for an explanation. If you find evidence that's not predicted, then you can get rid of that explanation. So what we do is science makes an explanation. We'll go over this like, why does my car not start or whatever. See, observation, you come explanation, the battery's dead, for example, or rats got in and ate all the wiring. That's another explanation. And those explanations make predictions about what, if it's true, let's say it's the battery. If you replace the battery, the car should start, right? but you test that prediction. That's an experiment. But a lot of times we can't do experiments. Astronomy, all we can do is observe. But it doesn't mean that we can't use a scientific method. We just don't have control like we would with an experiment, where we can control everything except a variable of interest. Let's say some drug that, some new antibiotic doesn't work compared to an old antibiotic. Okay, you can test that with an experiment, but sometimes you can't. First of all, there might be ethical problems, but also there's just, let's say, how can you, I would love to reproduce the Earth and run it back in time and let it march forward like it's done. And we can use that to test certain evolutionary predictions or theory, part of the theory of evolution, that what we might find. Not that we'd find humans or dinosaurs or bacteria or anything as the Earth evolved, but we would certainly find, let's say if we found life, we'd certainly see how life did evolve, and we make predictions. And it would be great if we could do that and then replicate the Earth, let's say 1,000 times. So we have 1,000 replicates. You need sample size to do that. But we can't do certain experiments. But we can still observe predictions that an explanation or a hypothesis or a theory can make, like I just said about gravity waves. So it's very useful. Now, like I said, we don't go around proving things. We actually go around disproving things. That seems completely screwy. Why would you go around disproving things? Well, it's philosophical in that it's nice to think, oh, I know what's going on. Like we have beliefs about everything, about what the universe is like, from everything from the clothes we wear and all that, about what's going to happen. But if we really want to find out what's going on and not miss an explanation, all we can do is blow up everybody's explanation. So someone comes up with an explanation and some other scientist comes along and blows it up. He's doing that person who first proposed that explanation, a favor actually, or she, because, well, that was the wrong path. All you can do is blow up. If you have one explanation then that's left standing, or a theory that has not been refuted, it means there's more and more and more evidence for that being true. Not that it's true, but that's at this point the evidence suggests that, like, there is climate change and it's man-made. Okay? The evidence is very, very strong. We can say that. But it has not been proven, and it never will be proven. But it doesn't mean that you would discard that, oh, it's only a theory. Those aren't theories. A theory is a completely different animal than it's only a theory. Okay, so we're going to be thinking about that. So here's a decent kind of explanation for what science is and what it does, enterprise, but most importantly, it's a process. And it can actually be a process that can be used in all sorts of different areas. History was always part of the humanities. Well, some people have been using the scientific method for testing historical hypotheses. Like I said, you can never know with certainty. There is no certainty in science. There's only likelihood. But it's one of the most reliable ways of getting knowledge. It doesn't mean it's the only way, though. For example, why would you want to watch Shakespeare and turn everybody, all the different characters, into behavioral phenotypes. A phenotype is the way an organism looks, behaves, acts, all that. And you know how there are people that are gregarious, and there's people that are sad, and there's people that are sociopaths, and all that. Well, I guess you could turn Shakespeare into that, but what's the point? There's a lot more you can get out of Shakespeare just because of the human interactions that are going on. But science is a very powerful way of gaining reliable knowledge because it's very rigorous. You can't just like play with, you can throw as many explanations out there as you want. I'll give you an example of an explanation. Why did the keys fall to the ground? Okay, gravity, right. Okay. But once upon a time in California, there was a cult that believed that the earth was hollow, and there were all these people inside it that had metal heads, and these people were the reasons that we actually had gravity. Okay? No, really. That's a decent valid hypothesis. The question is, what prediction does it make? Well, if gravity was really because of electromagnetism, the only thing that would fall to the ground would be metal. Anybody in here have metal in them? Yeah. That's why you're here and the rest of us are floating up. So we just disproved, in fact, that can't be. We don't know anything. I didn't say anything about whether there's actually people in a hollow earth. I just said that gravity cannot be that explanation. Because that explanation says that it predicts that only metallic objects should stay on the ground and not everything else. Okay? So that's what's great about science. You can be dead wrong, but it's self-correcting. Of course, there are cases where ultimately there's certain things we probably will never be able to know. In fact, a lot of things, but so what? So, yeah.
So by that definition of science, are there no laws?
A law is actually an observation. It doesn't, not an explanation. Like laws of planetary motion, okay? A theory is an actual explanation. And theories are always provisional or conditional. That means, according to the information that we have now, that's the best explanation. But like I said, with Newton's theory of gravity, it stood for 300 years. In fact, we still use it in terms of space travel. But the actual, the current theory of gravity is Einstein's theory of general relativity. Okay, and it's a much different explanation than Newton. Okay, so I'll see you Thursday. I'll get the moon set up and all that.